We mentioned briefly that if you have a large ISIS autonomous system, we can break this up into smaller areas. We'd probably want to do this because otherwise each device will have to maintain an identical link state database for the entire autonomous system, and this would eventually impact on device resources like memory, CPU, etc. When ASs are divided into areas, the separate areas must have a way to be able to communicate with each other, and that's what we're going to explain here. There are two levels of intermediate system. Level 1 intermediate systems root within an area and they can only form an adjacency with other intermediate systems within their area. Then we have the Level 2 intermediate system, which deals with routes between areas, inter-area routes, and can form adjacencies with intermediate systems from other areas. However, if a Level 1 intermediate system cannot form an adjacency directly with a Level 2 intermediate system, what happens? Well, an IS to IS router can act as both a Level 1 and a Level 2 router, and if the destination is outside of the area, the Level 1 router will pass the packet onto its nearest L1, L2 router that will form an adjacency with both L1 and L2 intermediate systems, and this will forward on the packet. The L1, L2 intermediate system sets the attached bit in the Level 1 packet. In IS to IS, packets are called protocol data units, PDUs for short, and this Level 1 PDU is generated into the Level 1 area to indicate that it is connected to a Level 2 backbone router and that it can be used to reach prefixes outside the Level 1 area. Level 1 routers then create a default route for inter-area prefixes which points to the closest, in terms of metrics, Level 1, Level 2 attached router. So ISIS Level 1 and Level 2. I have a pretty flat topology. Let's have a look at the topology that we're going to be using here. So we have 5 routers in a row, R1, R2, R3, R4 and R5. R1 and R2 are in area 49.0001. We have an interface in R2. Well, actually with ISIS, they say the whole intermediate system is within an area. So let's just have a look at the diagram here. R2 has a connection to R3 and R4, and these are in area 49.0002. And R4 has a connection to R5, which is in area 49.0003. R1 has a loopback address of 1.1.1/32, and R5 has a loopback address of 5.5.5.5.5/32. Now, we saw in the theory that as long as a Level 1, Level 2 intermediate system has a connection to a different area, it injects a default route into a Level 1 area so that any Level 1 intermediate system can get access. So what we will find is that R1 will not have an exact route to 5.5.5.5. It will have a default route. Now, this is not always appropriate, so we'll find a way to get around that as well. I have all of the devices open. Let's do our ISIS configuration. Then we'll have a look later on how we can get those specific routes into an area. So I've got all 5 routers open and I've done the IP addressing, but that's it. I mean, there may be some residue config left on the devices, but we'll look at that later on. Or we'll deal with that when we get to it. Yeah, so we should be able to ping R2. Which we can. I'm not going to test them all, and this may cause issues later on, but hopefully we're good enough now that we can deal with them. So I will just look at R3, might be a good one. R3. Oh, where is R3? Come on. R3. And we'll ping both directions. So we'll ping R2 first. Which is reachable. And we will then ping R4, which would be 34.4. Yeah, that's good. So let's get on with our IS to IS configuration. We'll jump back onto R1, we'll start there. And the first thing that we're going to need is to specify the ISO. So instead of having family INET, which is IP version 4, we need to have family ISO. And we also need to specify our NSAP address under the loopback interface. Loopback 0.0 family ISO address, which will be 49.0001, which is our area. And then we need our actual address. What I will do, I'll make all of our addresses 1.1111 dot 1111 dot 1111 dot 00. I will do this on all of the intermediate systems. Let's commit. Oh, that's not enough actually. We need to now advertise those interfaces into ISIS. Type edit protocols ISIS. And what I'm going to do, because this is going to be a level 1 intermediate system, I'm going to disable level 2 communications. So set level 2 disable. And then we're going to say set interface GE000.0 and also set interface loopback 0.0, and we're going to make it passive. Let's commit that. And we're going to do the same on R2, R3 and R4. I probably won't be saying much in this because I'll be concentrated. It'd probably be better to put this into a notepad, but I didn't do that, so let's just do the manual configuration. We don't disable it here because it's going to be a level 1, level 2 router, a level 1, level 2 intermediate system. Alright, that's looking good. Let's jump into device number 3. from the last one. Now, this is our ISIS configuration. So we should now see reachability to R4, have an adjacency to R4 on R5. And we should also see a default route allowing us to ping R1's loopback address. So if I say run show ISIS adjacency, too many I's, ISIS adjacency, and we can see that we have our connection to VMX R4, which is nice. Let's do a run show route for the protocol ISIS. Yeah, so we can see that we've got access to R4's loopback address, but for anything outside of our area, we're using this static route, our default static route. So we don't have particular routes. Now, for us to be able to see the actual attached bit, let's jump onto R4. And from R4, if we run, what is the command again? Run show ISIS database. And the system ID is, I think it's going to be what we saw here. Wait, on R5. So our system ID, VMX-R5. Yeah. So we have, I wonder if I can see it this way. Run show ISIS database VMX-R5 extensive, and let's do a match attached. I'm not actually sure how to see the attached bit. I would have expected to see it here. Okay, let's see that on R5 itself. Run show ISIS database for VMX-R4 extensive. Here we go. All right. So on R4, let me come out of this, and because there's a lot of output there. If I now do a pipe and say match attached, we can see that the attached bit has been set. And this is being sent to us from R4. That's the only way I know how to see the attached bit. If anyone knows anything better, please drop us a link at routercoach.com, and I'd appreciate that. I know that you could probably do it through like a Wireshark capture, but I don't know how to do it particularly on the box apart from this way. And this is showing that we've got the attached bit set, which gives us the default route. Now, if we wanted to see R1's particular IP address, or not even R1, any of the other particular routes, we're going to have to do something called route leaking, which will leak that particular route into the L1 area. Now, to do that, we're going to have to use policy, and I will run this policy on R4. So before we do that, let's just have another look at the route table on R5. Run show route for protocol ISIS. And all we see in the route table is R4's loopback, our link to R4's link to R3, and then a default route to get to any address anywhere else. Now, it still gives us reachability, but obviously there may be occasions where you want to see that particular route. So we can still ping R1's loopback, but we don't want to just be able to ping it. We want to also see that route in our route table. So let's jump back onto R4 and we go to the top and we could say edit policy options. Our policy statement is going to be called just R1 route. We're going to set from a route filter. Now our route filter is going to be R1's route, which is 1.1.1.1/32 exact. Now, if you wanted a network, you would say or longer, but because we know this is just a host route, we're going to say exact. Then we're going to say set from protocol. Our protocol is ISIS, and it's going to level 2. So it's coming from level 2, and we're going to say set to protocol ISIS, and it's going to level 1, yeah? To protocol ISIS, going to our level 1 router, which is R5. Then we're going to say set accept. Wow. Set, then accept. And then the final part of this, if we jump onto our protocol stanza for ISIS, top edit protocols ISS, set export this, and we're going to export it. What did we call it again? R1 route. Let's commit that. I hope you followed along. Pretty straightforward. You're just getting the particular route. You're setting it from which level it's going to. So it's coming from level 2, going into level 1, and then we're accepting that policy, and then we're exporting that policy. So if we now jump onto R5, after all of that talk, I hope it worked. We run show route protocol ISIS. Yeah, and here we see the particular route for R1's loopback. Okay, that's it for our level 1, level 2 lab. I'll see you in the next one.